This is the March 2011 paper, Unit 1, Statistics and Probability, calculator is allowed. Question 1 is a survey question. Dan is going to do a survey to find out how much time students spend playing sport. He is going to ask the first 10 boys on the register for his PE class. This may not produce a good sample for Dan's survey. Give 2 reasons why not. So they're telling us it's not a good sample for Dan's survey. We just need to know why. So there are a lot of reasons you can choose. The first reason is going to be bias. So that means that something's not fair. Now, it's bias on a number of levels. So you might have bias because of their age. So he's only asking people in his class. You might have it's biased because of gender, because he's only asking boys. You might have it's bias because he's only asking PE students. You may also comment on the fact that he's only asking 10 boys, so that is his sample size is too small. 10 boys is not enough. You also may say that his sample method, because he's chosen the first 10 boys in the register, the sample method is not random. And just a reminder that a random sample is when everybody has an equal chance of being selected. So that is a 2-mark question. You get 1 mark for any of the reasons. So any 2 of those and you get 2 marks. Part B wants you to design a suitable question for Dan to use on a questionnaire to find out how much time students spend playing sport. Now, these are always asking for 2 particular things. They always want time and they want boxes, but most importantly, units. So, a question for Dan to use on a questionnaire to find out how much time students spend playing sport. So that might be, how many hours do you spend playing sport? And here's the time frame. I'm going to say in 1 week. You may wish to do a year, you may wish to do a month, you may wish to do a day. I'm going to pick week. Now I need my response boxes. I need at least 3 response boxes. Now the boxes cannot be overlapping. It doesn't matter if they're exhaustive or not, so it doesn't matter if you've covered every possible option, as long as they're not overlapping. So I'm going to have this for people 0 to 1 hour. This is going to be people for 2 hours to 4 hours. This is going to be for people 5 hours and above. You can have more boxes, just make sure they do not overlap. And the way that the marks are divided for this is that you get 1 mark for putting in a time frame, so mentioning a week, a month, a year. And you get the other one for having non-overlapping boxes with units mentioned, so hours. Question 2 is a scatter graph question. A beach cafe sells ice creams. Each day the manager records the number of hours of sunshine and the number of ice creams sold. The scatter graph shows this information, so it's always worth familiarising yourself with the graph. Here we can see the number of ice creams sold, and along the bottom we can see hours of sunshine the day had. So, on another day, there were 11.5 hours of sunshine and 73 ice creams sold. Show this information on the scatter graph. So, 11.5 hours, so there's the hours, there's 11, there's 11.5. And 73 ice creams, so 70, 1, 2, 3. So that's 73 ice creams. And that's 11.5 hours. So I need to put a point where they overlap. So that's up there. There's 70, 1, 2, 3. That's a 1 mark question. You get the mark for putting the cross in the right place. Part B then asks to describe the relationship between the number of hours of sunshine and the number of ice cream sold. Now, the relationship needs to be a practical application of what you're looking at. So here we can see that the ice creams, the number of ice creams sold, go up as the temperature goes up. So that's exactly what the relationship shows. So, oh, not the temperature, the number of hours, sorry. So the ice cream sales increase as the number of hours increase. And this is called positive correlation. And that's a 1 mark question. One day had 10 hours of sunshine. Estimate how many ice creams were sold. Now, the fact that it's using the word estimate is telling you to use the graph. They want you to estimate. So what I need to do is draw in a line of best fit. Now, your line of best fit is going to sort of go through the majority of the points where you think, I quite like to turn my ruler to the side in order to do this. So my line of best fit is going to be somewhere along those lines. And I'm interested in how many ice creams sold for 10 hours of sunshine. So there's 10 hours of sunshine. I'm going to go up to my line and I'm going to show the examiner that I'm doing it. The benefit of this, of course, is if you've drawn the wrong line of best fit in, the examiner can see that you've had the method right and you can gain some other marks. So mine comes out as 64. So estimate how many ice creams were sold? 64. Now, on the mark scheme, because everyone's line of best fit is going to be different, they will accept 62 to 70. You will get 1 mark if your line of best fit is wrong and you've shown that you've managed to get your answer. Question 3 is a percentage question at the end and a ratio question at the beginning. So, a shop sells freezers and cookers. The ratio of the number of freezers sold to the number of cookers sold is 5 to 2. Straight away, I'm dealing with freezers and cookers. I'm going to set this out logically so I know what I'm doing throughout the question. So, the number of freezers sold to the number of cookers is 5 to 2. So for every 5 freezers sold, there are 2 cookers sold. The shop sells a total of 140 freezers and cookers in 1 week. Work out the total number of freezers and cookers and the number of cookers. Work out the number of freezers and the number of cookers sold that week. So we've got 140 sold in total. We've got 5 parts freezers, 2 parts cookers. First thing I do is find the total number of parts, which is 7. So there's 7 parts in total, and that 7 parts equals 140 items that have been sold. So what I want to do is use a unitary method and find out what 1 part is. So 1 part equals the 140 in total divided by the 7 parts. And that tells me that 1 part is worth 20. Now, the fact that the ratio is 5 to 2 means I can multiply this 20 by 5 to find out how many freezers were sold, and multiply by 2 to find out how many cookers were sold. But I'm going to just lay it out in a little clearer way. So I'm going to say freezers equals 5 times 20, which is 100, and cookers is 2 lots of 20, which is 40. And I'm just going to do a quick check. If I have 100 freezers and 40 cookers, does that give me my total? Yes, it does. Now, the way that the mark schemes are allocated for this is you get 1 mark for doing basically the ratio process. So finding out what 1 part is would get you 1 mark. Or you could also get that mark by multiplying whatever you consider 1 unit to be by each of the items. The second mark is an answer mark that comes from having 140 as 2 answers. And then the third mark is a communications mark, and that's for stating really clearly that the 100 links to the number of freezers and that the 40 links to the number of cookers. Now, part B, Jake buys this freezer in the sale. The price of the freezer is reduced by 20%. Work out how much Jake saves. So the question wants to know how much he saves. So 20% of £145. That's what my question wants to know. It's always worth setting it out as a very clear example so that you can apply the maths. So 20%, well, percent means out of 100. So that's 20 out of 100 of is times, and that's 145. So this is a calculator paper, remember. I can put in 20 divided by 100 and press equals, and then press my SD button, and that'll give me the decimal of 0.2. Then I press times, and it's 145. And 0.2 times by 145 equals 29. So Jake has saved £29. That is a 2-mark question. The marks are allocated as 1 mark for showing whatever method you chose to get your percentage, and the second mark is the answer mark for getting £29. Question 4 is one of those questions that throw a lot of information at you, and you're expected to set it out in a logical way, and one which is ultimately going to leave you to the final question, which is to work out the number of students who had a packed lunch. So always keep in the back of your head that's what you're going to try and find. Alright, a teacher asked 30 students if they had a school lunch or a packed lunch or if they went home for lunch. So I've got 3 options of lunch there. That's one thing they're telling me about. Lunch. 3 options. 17 of the students were boys. 4 of the boys had packed lunch. 7 girls. So straight away I'm going to make a note here that it's broken down by gender. So there's two variables there that I'm looking at. It's the type of lunch that people had and whether the people were boys or girls. Because I've got 2 different variables that I need to sort, I'm going to use a 2-way table. And the 2-way table is just going to help me set out my question. So I'm dealing with a packed lunch, a school lunch, and a home lunch. Total. I'm dealing with boys and girls. Total. Now, setting a table out like this just allows a little more clarity from what is a big chunk of text. So the first thing I'm noticing is that a teacher asked 30 students. So the total all together, everyone involved is 30. Now I can quite easily place my other information in this grid. So 17 of the students were boys. Boys, all together, 17. 4 of the boys had a packed lunch. Boys, packed lunch, 4. 7 of the girls had a school lunch. Girls, school lunch, 7. 3 of the 5 students who went home for boys. This could be a little bit confusing because it sounds like it should be a fraction, but it's not. It's saying 3 of the 5 students who went home were boys. So they're saying 5 students went home, and they're saying 3 of those are boys. So that's all the information that they've given me in the question. And so far, just for setting that up, I've got 1 mark. Now for my second mark, I need to use that information to find out any of the missing fields. So I could start here and say that I know there's 17 boys in total. There's 30 people altogether in total. That must mean that 30 take away 17 leaves me with 13 girls altogether. Or I could have said that my home lunches, there were 5 people altogether, 3 of them were boys, so 2 of them were girls. So I can get a mark for either of those. That's 1 mark. Then I could have taken the approach of, if I know there's 13 girls altogether, then there's 2 had home lunch, 7 had school lunch. That means the remainder had a packed lunch. So that's 4 girls having a packed lunch. And from that, keeping in mind that my question was the number of students that had a packed lunch, I found my answer there. It's 8. But there are other ways of getting to it. I could have also said, well, there are 17 boys in total. 3 of them had home lunch, 4 of them had packed lunch. 17 take away 3, take away 4, leaves me with 10 boys that had school lunch. For finding the second one of the values, that would give you another mark. So you would get an answer mark for getting any 2 of those. You'd get the second answer mark for getting any one of those. And then you'd get your final mark for correctly identifying that there are 8 students that had a packed lunch. And I'm just going to make that statement down here. Packed lunch is 8 students. Question 5 is a probability question. And it reads, the probability that a seed will grow into a flower is 0.85. Lauren plants 800 seeds. Work out an estimate for the number of these seeds that will grow into flowers. Now I know the probability of something growing is 0.85. I need to estimate what 0.85 of the 800 seeds planted is. So 0.85 of 800, keeping in mind that of represents a multiplication operation. You type into your calculator 0.85 times by 800 and that gives you the answer of 680. It is a 2-mark question. You get 1 mark for showing the multiplication. The second mark is an answer mark. Question 6 is about the mean, but it's more testing your understanding of what the mean is. So there are 15 bags of apples on a market stall. The mean, so average, the mean number of apples in each bag is 9. The table below shows the number of apples in 14 of the bags. Calculate the number of apples in the 15th bag. Well, first of all, I know that if there are 15 bags and there are an average of 9 apples in each bag, then 15 bags should contain 15 times 9, which is 135 apples, approximately. So let's find out how many the 14 bags is worth. So there are 7 apples in 2 of the bags. 7 times 2 is 14. There are 8 apples in 3 of the bags, so altogether there are 24. There's 9 in 3 of the bags, 27. There's 10 in 4 of the bags, which is 40. And there's 11 in 2 of the bags, which is 22. I then total those together, and that gives me 127 apples. So that is for 14 bags. Now, I know that in 14 bags there were 127 apples, and in 15 bags there were 135. So the difference is the 1 bag. So I'm going to take my 135 apples, I'm going to subtract the 127 that were in the 14 bags, and that's going to leave me with 8 apples. So there were 8 apples in that final bag.